Let's solve an example problem that involves a projectile launched horizontally. So this says determine the range, that is how far an object lands from its base point. So essentially the range is just the horizontal distance traveled. So if I had something that was at the top of a cliff and I threw it this way and it landed on the ground, the distance from here to here, that's the range. Okay? So determine the range of a projectile launched horizontally from a height of 3 meters if its initial velocity was 20 meters per second. Alright, now remember, when we're solving horizontal projectile motion problems, or really any projectile motion problems, we need to keep our x's and our y's separate. We need to keep our horizontal motion independent of our vertical motion. So we've got to sort through this information and put it where it goes. So I'm going to keep my column for x information, and I'm going to keep my column for y information, and I'm going to make sure I keep those separate. So it says that it's launched horizontally, which means initial velocity in x is 20 meters per second, because it was given an initial velocity of 20 meters per second, but the initial velocity in y is 0 meters per second because it was launched horizontally. Acceleration in x is equal to 0 because the projectile only has one force acting on it, and that force is the force due to gravity. So the acceleration in y is negative g, negative because I'm choosing down to be negative. Let's see, what else do I know? I do know that it had an initial height. It was launched from a height of 3 meters. So its initial position is equal to 3 meters. And I also know its initial position horizontally, not because it was told, but because I'm going to assign it. I'm going to say its range is from where it was launched to where it landed, so I'm going to say it started at 0. So my initial position in the horizontal direction is 0. I also know that it will be at its maximum distance when it's on the ground. So I know its final position in y is 0 meters. Now, I don't know its final velocity in either direction, right? I know after it hits the ground it'll be at rest, but when it hits the ground it's moving, so don't do anything with final velocities. The only time we say something's velocity is 0 for a projectile is when it's at its highest point, which is why our initial velocity in y is 0. If it's launched horizontally, it starts at its highest point and it falls from there. So this is the information I have, and the information I want is where does it end up. I want its final horizontal position. Well, in the horizontal direction, I know x is equal to 1/2 at squared plus v naught t plus x naught. Now I assigned x naught to be 0. I know its initial velocity, I know its acceleration, but I don't know time. So I have x equals v naught x times time. Okay? So if I know how long it's in the air, I will be able to figure out how far it moves. But I don't know how long it's in the air because the horizontal direction has nothing to do with that, right? However, I do know enough in the vertical direction that I can figure out how long it falls. So let's go to the vertical direction. In the vertical direction, same equation, y equals 1/2 at squared plus v naught t plus y naught, but now I'm going to use all my vertical information. So y, its final position is 0, is equal to 1/2 of negative 9.8 g times t squared plus initial velocity in y is 0 plus y naught, and my initial position is 3. And so now I'm going to simplify this. I'm going to get 0 equals negative 4.9 t squared plus 3, and then I can add the 3 over. I guess technically it's subtract it, or I could add over the 4.9 t squared. Regardless, I get the negatives to go away. 4.9 t squared equals 3. I can divide both sides by 4.9, and I get t is equal to the square root of 3 divided by 4.9. That's how long it takes the ball to fall. Notice that that's its height divided by half g. This equation was nice and simple because there was no v naught term. If there was a v naught in y, then we'd have to do a little bit more math. We'd have to use the quadratic equation to solve for t. That's okay, we know how to do that. So now I have time, and I can take time and I can plug it into this equation, and so I get the position that's ranged where it lands in x is equal to its initial velocity in x, which we know is 20, times the square root of 3 over 4.9. And that gets me its final position in x. So I use the y direction to figure out how long it had to fall, and then I use that time in the x direction to figure out how far it moved in that time.